and he thought he could escape us, but no.
No, already was already hijacked before, but very briefly.
Yeah. So you are. Oh, he's fantastic.
Yeah, technology is amazing.
Magic. So what are you tinkering on?
A lot of stuff. Mostly, I'm trying to organize better my education effort because I'm very tired of consultancy. So I'm trying to ditch banks for consultancy, which are very good money wise, and to start doing courses and workshops, which are a little bit more difficult to organize and to monetize. But let's try. And technology wise, I'm still sponsoring open source nonprofit initiative. Mostly, I'm focusing on layer 2 and 3 application like timestamping, proof of publication, and asset with RGB. The RGB effort, the RGB project, which is in a way what we will talk about in our talk here tomorrow. It's getting a lot of attention because it has an actual use case, which is basically tokens. So mostly what we are interested is like Tether
Shit
US
coins.
dollar. Yeah, there are a couple of shit coins that I kind of like. For example, Tether. If you think about Tether, it's very centralized, very risky, but it can be a way to actually overcome KYC in trading, especially in the secondary market, because it separates the complex trading stuff from the digitalization of US dollars. So if we assume that in hyper-Bitcoinization, the wealth is going to move from dollars to Bitcoin, you need bridges, and the more these bridges can use a regulatory arbitrage like Tether does, the better. So I like the Tether shitcoin, one of the shitcoin I like, and I don't like the fact that they have to use either Omni, which is a very legacy protocol on Bitcoin, or shitcoins protocol like EOS, Ethereum, and stuff like that. So I'm excited for the idea that they can start using proper technology like liquid confidential assets or RGB confidential assets. The idea is to RGB is not a competitor of liquid. It's a different way to use a similar technology about confidential assets, but committed directly on chain. So I would say it's a complementary effort, and we are talking with Blockstream a lot in order to make it interoperable. But the nice thing is that this RGB stuff is an example of many things that you could do once you have Lightning Network working. So we talk about layer 3 solutions, meaning that once you have properly arranged trustless payments, you can build, for example, generalized message passing systems on top, incentivize, and that can become now I start talking like a shitcoin, but imagine a future in which you can use monetize, incentivize message passing system in order to build mesh networks with incentive mechanism and storage system, this distributed storage system with incentive mechanism, maybe incentivize distributed computation, zero knowledge. So you can do a lot of, let's say that a lot of the ideas that shitcoins were based upon were not completely absurd, just too early, exaggerated in their effects, and maybe not yet ready because they didn't have all the ingredients ready. Now we can start to think about some science fiction applications. So I'm very happy.
Yeah, fantastic. Absolutely right. And especially RGB. I started to more look into it and trying to wrap my head around it. And it's like a quite brilliant solution. It has a bunch of complex magic happening in the background. But I think if like the protocol itself will work out into conceptual flaws, this might be very interesting.
Yeah, it's RGB has an interesting story because the idea is that the main core of the idea is Peter Tort's proposal of client-side validation. So the point is, when you are not moving Bitcoin but something else, don't use block space, the time chain block space, in order to see what I did there. In order to sneak, in order to try to free ride other people's storage and bandwidth. Don't do that. Use the time chain only for the thing that it does good, which is preventing double spending, and everything. Exactly. Well, that's more than that. Peter will be angry about that. It's not time stamping, but let's say time sealing. You are not stamping. You are not guaranteeing the date of a data, but the unicity of a data over some kind of space, which is what can prevent double spending. Time stamping is very easy to scale. You can aggregate millions of documents into one the proofs of millions of documents into one Merkle root. Just print the on chain the Merkle root, and you timestamped everything. Like Peter Todd and Riccardo Casato, they timestamped all the internet archives in one Bitcoin transaction, and they created a bot that every 5 minutes timestamped all the internet archives. Every single HTML tag was Merkelized, and the root was in an operator, and so they could just use one operator to Merkelize the entire. So timestamping is easy. Time sealing, let's say, proving a publication, which is what Bitcoin does, is difficult because you cannot aggregate, because if you aggregate, you cannot prevent double spending. So that's more challenging from a scalability point of view. What Peter is working on is something called Proof Marshal, which is basically a way to aggregate a little bit of these proofs in a way that scales better and it's more private, but it's still prevents double spending. The thing is that this idea of client-side validation is cool, but I have at least two major drawbacks. The first is that you have to be online all the time to receive, because I am passing all the metadata to you directly. I'm not putting them on chain. And the second is that you basically cannot backup just the seed. You have to backup all the proofs, the off-band proofs. But what is very interesting is that with Lightning Network, you have this exact same problems with channel states. You have to be online to receive an update directly. It's not a global consensus system. And you have to back up somehow your past channel states. So the idea of client-side validation that was too challenging from a UX point of view before, with Lightning, can just leverage the same kind of solutions of Lightning itself. So it becomes more feasible, let's say.
Yeah, absolutely. Yeah, you see, and just, this can all build on top of each other, right? And utilizing the strengths of one layer to build on top of that with, some other trade-offs to make sure everything somehow works out.
Yeah, and the role I try to fulfill is exactly, every one of these solutions can build on top of the others, but it's very difficult to coordinate because everybody is redoing the same, reinventing the wheel. There are a lot of redundancies or a lot of parts that are then being less exciting. Nobody is doing. I mean, everybody is doing duplicates of the same thing, and nobody is doing something else because it's less exciting. So what we're trying to do is to give a little bit, to create a little bit of centralization in development, meaning that we try to coordinate and to incentivize the part that are less exciting and to reduce redundancy in the part that are more worked on. So standardization in a way.
And of course, there might be some problems with the current bold specification of Lightning. Many. So there's also the LNBBP, just entire general stack. So Lightning Network Protocol, Bitcoin Protocol.
Yeah.
What is that standardization you're working on?
So the main idea is that after we acquired the knowledge that layerization is the best thing to do, is the way forward. We have seen that the internet, for example, the IP layer with the TCP layer, with the HTTP layer, and so on, is pretty layerized, and probably the future ecosystem around Bitcoin will be layerized as well. Right now, the layerization is very dirty, very ugly. That's normal because any organic, ISO-OSI protocol was designed by bureaucrats, and so it was very clean, but it was never used. As opposed to the real internet, TCP/IP, it was messy because it emerged spontaneously, but it required a lot of effort to clean it up a little bit in order to make it reasonable. The same goes for LNPBP, so the analog of TCP/IP, like BP. The Bitcoin protocol is like the internet protocol, IP, and on top of that you have a layer which is we call it TCP, but it's not just TCP itself. It's a name, it's a placeholder for TCP, UDP, a lot of other possible layer 2 internet protocols. The same goes for LNP, Lightning Network Protocol, but also maybe other, side chains, state chains, other things that rely on the underlying settlement layer. And so the idea is that what we are doing on RGB is part of a more global effort to create standard primitives, standard building blocks. It's not that we are really creating them. We are trying to take what smart people is doing and standardizing a little bit and put it together in a way that is kind of organized. It's very challenging, but if we succeed, we hope that it's not so unlike the effort that Bitcoin was doing. The idea is to create a stack of two very simple tools which are reproducing what smart people created. So we don't reinvent the wheel, but we try to create an anthology of tools.
And of course, like the challenge that the Bitcoin has is that Bitcoin Core, Bitcoin D, is the reference implementation, is the spec itself, all the bugs, all the flaws, all the inefficiencies that it has.
Yeah.
And since it's a 100% consensus system, the Bitcoin needs to include all the bugs and all this nonsense from Bitcoin D, right, in order to still stay in consensus.
Yeah, the global consensus systems are such that you have to avoid failure of consensus at any cost. And so basically you cannot really, there was a lot of discussion about Ethereum or other shitcoins having a written reference specifications and Bitcoin being just code. But actually, when you want to avoid any kind of unpredictable side effects, you need code. You can, I mean, what you need is a written specification which is so formal, so verifiable, and so specific, and so accurate that actually that's code. The only way to, I mean, the reason we invited the reason human beings invited programming languages and we don't talk with the computer just in English is that English is too ambiguous. When you want to specify something at the level which is so precise that even a machine can understand it, that's basically creating a programming language. So the idea, mostly pioneered by Peter Todd himself, is it's good that Bitcoin doesn't have a high-level English reference implementation. And indeed, what's one of the problems with Bolt may be, I mean, we are partially responsible for that because the Bolt specification effort started in Milan with the Milan Protocol Initiative when we gave our, basically my role there was just to bring pizza to Light Labs.
By far the most important job, right?
Yeah, absolutely.
If the
absolutely.
hackers don't have pizza, coffee, and beer,
they cannot,
they're not going to get shit done.
But the result of that, we were super happy in 2016 when from our office we were seeing the magic happening of people coming out with the Milan Protocol that then became Bolt. But Bolt was a natural language specification, and what we have seen with the recent bug is that basically when you have the natural language specification, some parts can be omitted, and you don't have a compiler telling you that. You don't have a debugger, so you cannot compile the specification. So one little part was missing because it was considered obvious, and everybody relying on the specification in order to build the implementation just consider that, ignore that part. I think that tomorrow in this talk by Maxime, that will be just after mine, Maxime will try to do a very cool stuff. You take the technical layerization of Lightning, so the messaging, punishment, all the layers, and you try to chart the bolts on top of that, and the result is very ugly. Like some parts are super over specified with a lot of even a little bit conflicting specification across bolts. Some parts are completely untouched, like the bolt part do not discuss those parts of the protocol at all, and many bolts are cross layer, so there is not a neat division across layers like internal layers of Lightning. So it is messy, and the good thing is that now many people, for example, another effort that is similar to Bitcoin is the Rust Bitcoin specification. The good thing is that when we move to layer 2 and layer 3 stuff, that problem that you mentioned, so lib consensus, basically, the fact that you need a reference implementation that takes the role of a specification, you can ignore that. You just you strip core of most functions. You use core in C++ what it is, and then you just build all the tools on top as a standard libraries.
Yeah, fantastic. So, how can we, or what are the next steps for this? Are you just gonna kind of like copy the bolts and rip them apart and make sure that they are more properly separated, or?
So since the money I'm managing to get right now is for RGB specifically, because we have Bitfinex interested in doing Tether on that. We have a Valtoro interested in doing VGold on that. We may have somebody interested in doing collectibles. So since tokens are easily monetizable stuff, we will focus on RGB and Spectrum, which is the Spectrum is basically the idea that if I create a token aware channel with you, and Mad Bitcoin creates a token aware channel with her, but you don't have a token aware liquidity, we can bridge Bitcoin liquidity. So I can give you a token Lightning transaction, which is HTLC conditioned to the fact that you give a Bitcoin transaction that is connected with another token transaction on your routing way. So the idea is that you can use Bitcoin to bridge, but then your Lightning node, Lightning's RGB node, which is called Spectrum, will be basically a trading bot that must have like a bid and ask spread, which is very complex. That's called Spectrum. So the idea is we will focus on these. So we will probably replace two. We are starting from C Lightning because I like LND and Clear is very modularized. It's less monolithic, so it's easy for us to play with it. We take a few daemons, basically the gossip daemon and the channel daemon. We rewrite those from scratch in Rust in a way that is compliant with these higher layer 2 or layer 3 applications. Then we create a complete set of libraries for this specific use case. When we have that, if we are successful, maybe we can expand to other daemons, other part, but we are not redoing the board specification again. We will just write collecting or writing code.
Very good. Writing code, good work.
Said by me, but I cannot. I couldn't write any code because I have mental issues. For example, I used to write code in Lisp or like concatenative language like Joy, very academic stuff that nobody uses. When I see something like a C-like syntax, my mind just fades. So I cannot write code. I can try to give money to people to write code.
Money, pizza, beer, and coffee.
Exactly. I provide money and pizza, basically.
Okay, Giacomo, fantastic work.
Thank you.
Quickly, where can people keep up to date with RGB, with LB and LNPBP?
So there is a repo, LNPBP repo, but it's just a few RGB stuff. If you go to the Telegram group of RGB org, you can find a lot of discussion about RGB.
Fantastic. Giacomo, thank you very much for joining.
Thank you.
Keep up the good work.
Thanks.
Bye-bye.